Okay, today in IM1 we're going to do a review on slope. I heard that you didn't get much time on this last year, so we're going to go over it again. The slope is the ratio of the vertical rise to the horizontal run between any 2 points on a line. And if you look at all these pictures, they are depictions of slope, whether it's steep or not so steep, but we all can think about slope when we're going up or down a hill or a road or anything else. Okay, so the rate of change, which is the slope, is a ratio that compares the amount of change in a dependent variable to the amount of change in an independent variable. That triangle is a symbol for change, so that's why I put it there. And it's the change in the dependent variable over the change in the independent variable. We like to say it's the change in the rise over the run. Okay? Change in y over change in x. For any 2 points on a non-vertical line, this ratio is constant. What they're saying there is when you have a line, non-vertical, then you look at any 2 points and you would get the same slope. Doesn't matter which 2 points you use, you will get the same slope. The constant rate of change of a non-vertical line is called the slope. So this is your slope, is the rise over the run. Okay, so here's some more ways of saying it. The rise is the difference between the two y values, and we're going to look at the formula a little bit later. The run is the difference between the two x values. You have to pick 2 points and use that. And we show the little man running up the hill. I use that later when I describe how to calculate slope. So the little man is always running right to left. Okay, it's going this way. So the slope of the line, here's the formula. We're going to talk about that a little bit later. And here's how you can find slope just by using a triangle. And we're going to go into that in more detail as well. Okay, so the small numbers to the right of the variables that you just saw in the formula, which the formula is y2 minus y1 over x2 minus x1, are read x1 is x sub 1. Okay, I don't usually say that, I just say y2, y1. But the subscripts, the important thing to remember is that they don't have any value in the arithmetic of the number. They're just telling you that these are from the same point, point number 2. And these are from the same point, point number 1. Okay, so when I'm talking and teaching about slope, I like to start with a story about positive slope. So we always think of the little man running left to right. And so if the little man's running and he can keep going up this hill and he can finish the race, that's a very positive thing. So we look at that and that's a positive slope. Okay, a negative slope is when the little man's running and he hits his head on the line and he gets knocked out. That is a very negative thing. So that's the best little story I've been able to give my students to help them remember. So just remember, he's always running left to right. Okay, when we're finding the slope of the line, we have instructions to follow. It says begin at one point and count vertically to find the rise, then count horizontally to find the second point to find the run. So there they go, up, the rise is 3, and then the run is -9. So that would be a rise of 3 and a run of -9, okay, which would be -1/3. Now, you could have started at the other point. There we go. See, the slope is there. And now we could have started at the other one. We would have had a rise of -3 and a run of 9. Well, that's going to equal the same thing. Now, one of the points I like to teach my students is that you can just do the triangle, like they've made this little triangle here. You can do the little triangle and count the numbers and not worry about the positive or negative, and then just look at the line and say, oh, my little man's running and he hit his head, so it's a negative slope. So if you forget to count which one's up, which one's down, which one's negative, which one's positive, then just put your numbers in place and then look at the graph and consider, is it positive or negative slope? Okay, so when you're calculating the slope, you want to start with that by looking at the line. You want to start with that little triangle. So you go straight over from one point and then down to the other point. Whoops, go down. All right, and then you're going to count the points. So when you do this, you got to be really careful. So I'm going to start over here. 1, 2, 3, 4. So my run is 4. Make sure the run goes on the bottom. Okay, it doesn't matter which one you count first. And my rise is 1, 2. So it's 2 like that. So there's my rise. Okay, now I look, is the little man is running, okay? And he hit his head and he's knocked out, so it's negative. So it's negative 1/2 is my slope. And I could have done it from the other direction. I'll do it with a different color highlighter. So I could have gone down from here and over, and I would have gotten the same numbers, 2 and 1, 2, 3, 4, which would have given me the same values that I got before. You can see both of them, okay? And don't forget, the last thing you look at to double check is it a positive or negative slope, okay? All right, so finding the slopes of horizontal and vertical lines, if you were going to take the time to do the rise over run, we notice that it's 6/0 because there is no run. So a vertical line, the slope is always undefined. Okay, a horizontal line, we have 0/12 is 0, so a horizontal line, the slope is always 0. And rather than do the calculation, I would say just memorize that fact that a vertical is undefined and a horizontal equals 0. Okay, so this is showing you how they calculate the formula for the slope of the line. So if you look at this, you've got x1 here, you've got x2 here. The difference between these 2 points is, and they always do the higher number minus the lower number, you're less likely to get a negative and a confusion there, so they always do the second one. But you could choose either point to be your x2, y2. So if I chose this to be my x2, y2, then this would be my x1, y1. It doesn't matter which one you pick, just remember that you have to use them in the same point, okay? So I'm going to erase that to avoid a little bit of confusion. All right, so now I've got that. You can see that the distance between these two is that, and then the distance between my two y's is this. And that's how they get the formula, but remember it's rise over run, so the formula has to be written that way too. So there you go, it's the change in y over the change in x. And this is how you calculate it. This is the slope formula. Okay, so you make sure that when you put the formula, when you put your points in, that these are from the same point and these are from the same point. Okay, that's the key, because that's where lots of people mess up, is they'll do this and they'll get a totally wrong answer. So make sure that your points from one are there and the points from the other are there. And you can use any 2 points. I could use these 2 points, I could use this point and this point. It doesn't matter, you will get the same slope. Okay, so we're going to use that formula, y2, maybe it's up here, there it is right there. Okay, so we're going to go, I always like to do this because this is y2, right? So I just do this, so I get 1 minus 5 over 8 minus 2. That's negative 4 over 6 is negative 2/3. And you always want to simplify your slope and get it into the least fraction that it is, because you're going to be using that when you start graphing. So make sure that you're careful with that. Okay, now just to show you, if I had chosen to go from the first point to the second point, let's say I used 2, 5 as my x2, y2, then I'm going to go the opposite direction, and on top it would be 5 minus 1 over 2 minus 8, which is 4 over negative 6, which is negative 2/3. These are the same. Remember, negative 2 over 3 is the same as negative 2/3, which is the same as 2 over negative 3. So once you know that the negative can go anywhere, then you can move it if you need to use it in a different place. Okay? All right, let's do the second one. We're going to go negative 2 minus negative 2. Remember, if you have a negative, you're substituting for this, okay? And then we've got 7 minus negative 2, zip zap that. This becomes negative 2 plus 2 over 9, which is 0 over 9, which is 0. And then you stop and say, well, how can that be? Well, look here. My y is the same. My y's are both negative 2. Whoops, my y's are both negative 2. And so that means it's a horizontal line. Okay? Everybody got that? Okay, so you take a second and try this one, and then we'll do it together. Okay, so negative 4 minus negative 7 over 6 minus 5. I'm going to zip zap that, and I get 3 over 1. So my slope is 3. Okay? All right. So remember, there's 4 types of slope. There's the positive slope, when your friend gets to finish the race. There's the negative slope, when he gets knocked out. And then there's the 0 slope, which there's no slope, so you can just walk that or run it and be fast. And an unidentified, you can't run up that hill, so it's undefined. Okay? All right, so if I was going to look at each of these, what would I say each one was? So hopefully you would say this is positive. Little man finished his race. This one's negative. The little man got knocked out. This one is undefined because it's a vertical line. And the last one is also positive because you can finish the race. Okay? All right, remember that slope is a rate of change. In real-world problems, finding the slope can give you information about how a quantity is changing. In word problems, look for these words. Okay, all of these words help you find the slope. Okay, and the slope is the word that comes before, and then x is what comes after. So whatever word comes here will be the value of your x. Okay, so we've got the graph shows the average electricity cost in dollars for operating a refrigerator for several months. That means my x is months. Okay, could be an m if you want. And so what goes in front of that? Oh, well, I don't know. I have to find the slope. Well, fortunately, they gave me 2 points. So I'm going to start by saying this is my x2, y2. And I'm going to start there. And so I'm going to go 24 minus 12 over 4 minus 2. And that is 12 over 2 equals 6. So the slope of my line is 6. Okay, so what does that mean? What does the slope represent? Well, if you look here, okay, this is giving you all the information you need. It's giving you, it's the cost of electricity over time. And then to be more specific, it's the dollars per month. These are the ones that you want to calculate. So what does it represent? It represents that the cost of electricity to run this refrigerator is increasing, because we do have a positive slope over here, okay, at a rate of $6 each month, or $6 per month. Okay? All right, let's try another one. Okay, so the graph shows the height of a plant over a period of days. Find the slope of the line, then tell what the slope represents. So again, I'm going to use the top number as my x2, y2. So I go y2 is 20 minus y1, sorry, that's y1, okay, over 50 minus 30. So I get 10 over 20 is 1/2. So what does that mean? Okay, so look over here again and over here, and it tells me that my plant is growing 1/2 centimeter per day. Now I want to ask you something else that's kind of curious. Where's my y-intercept? Why don't I have a y-intercept on this graph? What does that tell you? Well, it tells me, if I kept going with my line into the part that isn't real anymore because we don't have negative height. We don't have negative height, but we do plant the seed under the soil, and that's telling me that it took 10 days for that seed to show. And so that's why I don't have a y-intercept on this problem. I thought that was kind of cool. All right, so if you know the equation of a line, you can find its slope by using any two ordered pair solutions. So if it's in standard form, it's often easiest to use the ordered pairs that contain the intercepts. So we're going to do the cover-up method, and we're going to go negative 2y equals 16 because we covered up the 4x. And so now we get negative 8, and then we're going to cover up the negative 2y, and we get 4x equals 16, x equals 4. This gives us 2 points. Now when they're in a t-chart, I like to go from the bottom to the top like this. So it'd be 0 minus negative 8 over 4 minus 0. Zip zap, it's 8 over 4. That's the slope of my line, which is 2. I can check it by taking my equation and converting it to slope-intercept form. So let's try that. So we get negative 2y equals negative 4x plus 16. Divide by negative 2 every term, and we get y equals 2x minus 8. And so there's the slope, and there's the slope, and we verified that it is the correct slope. Now, one thing very important that I want to tell you guys is never leave your slope like this. Let's say you had a slope that you calculated and it looked like this. If you leave it like this for a test, you will lose 1 point, because I don't know if you know that that means it equals 2/3. You might think it equals a negative. So always simplify and get rid of those negatives. Okay? All right, so you try this and see how you do. Okay, so I'm just going to tell you that this is 4 and this is 6, and the slope you should have gotten is negative 2/3. So if you didn't get that, try to figure out what you did wrong and go back and start again. Okay, a line's slope is a measure of its steepness. This one, the slope is 0. It's a nice flat line. However, this one looks pretty steep. Some lines are definitely steeper than others. So if we look at a real line, which one's steeper? Well, just think about which one would you want to walk up. So this one would be a nice walk. This one, we'd have to walk a little harder. We'd have to really struggle a little bit. Maybe we'd want a rope to help us. So this is the steeper line. Okay, so one of the explanations that is given in the books is to use the absolute value to calculate your slope. I think that's kind of confusing, so I just tell students, look at the number, ignore the negative. So if you look down here, 4 is much bigger than 1/2, so the steepness of this line is much greater, and that's easy to see. Think about walking on the hill. This wouldn't be such a bad hike. This would be a very difficult hike. You might want to rappel on this one, use ropes. When we're looking at this one, if you compare 2 to 1, which is pretty much doing the absolute value, but we can see that this one would be the steeper line. When 1 is negative and 1 is positive, you still just look at the number and it will give you which one is steeper. So that's what I like to explain it. Using absolute values sometimes gets confusing and it's a lot more work. So I just say look at the number and which one is higher, and that's the steeper line.